This is a recording for pre-calculus, and this is 5.4 part 3. And so I'm working on pacing myself, not super great, but hopefully we're catching up. And in this part, we're on problem number 4, and it is to write the cosine parentheses arc tangent 1 plus arc cosine x parentheses as an algebraic expression. And so notice it's the cosine of something plus something. So we are going to use one of these sum formulas. And then we're also going to kind of figure out some relationships. And I think we'll use little right triangles to do that because we've got the arctangent of 1, and we're going to set up a little triangle with a ratio there, and we've got an arc cosine of x. So first, let's write our what we're going to use. Well, first I'll maybe write the problem. So this is for, I want the cosine of the arc tangent of 1 plus the arc cosine of x. And I'm going to remind myself of the sum formula for cosine. So cosine of u plus v is cosine u cosine v minus sine u sine v. So cosine u cosine v minus sine u sine v. So obviously I have to figure out sines and cosines for each one of these. And I'm going to kind of color code this as I go. So this arc tangent 1, that's going to kind of give me something in relationship to that u. So I'm gonna just deal with this arc tangent 1 as a first thing. And I'm just going to draw a little right triangle. And we know if for the arctangent of 1, we know that that means that the tangent of, I'll call it u. Oh, sorry. The tangent of u is equal to 1 over 1 is how I'll say that, I guess. So if u is right there, and tangent is opposite over adjacent, those are 1 and 1. And so this is an isosceles right triangle, and this is the square root of 1 squared plus 1 squared, so this is the square root of 2 on that hypotenuse. So without knowing what u is, although we probably do know what u is, we can say the sine of u is 1 over the square root of 2, and then we'll rationalize that denominator by multiplying by the square root of 2 over the square root of 2, and that is going to give us the square root of 2 over plane 2. So that's what the sine of u is, and then the cosine u is going to be really the same thing, 1 over the square root of 2, and so that's going to equal the square root of 2 over 2. And maybe I'll just clone that and just slide it in there to rationalize that denominator as well. So those are the values that we're going to use. And so cosine u is going to go right there. Sine of u is going to go right there. And then we'll do the same thing. Let's get rid of all that yellow. We'll do the same thing with the arc cosine of x. And so I'll maybe use this arc cosine of x. Maybe I'll use a different color, maybe red. So the arc cosine of x, that's gonna, I have to get the cosine and the sine. So the arc cosine of x means, and I just don't like the way I wrote that, arc cosine of x. That means if I have a little right triangle here, and I have, we'll call this one V, And this means that the cosine of v is equal to x over 1, we'll say. And cosine is adjacent over hypotenuse, so this is x here and 1 there. This is the square root of 1 minus 1 squared minus x squared, so 1 minus x, the square root of. And so the cosine of v is what we need. We also need the sine of v, and the sine of v is going to be the opposite over the hypotenuse, so 1 square root of 1 minus x squared over 1. So we can just rewrite it as the square root of 1 minus x squared. So then for this one, we need the cosine of v, which is just going to be x, and we need the sine of v, which is going to be this square root of 1 minus x squared. So now that was my formula and everything. I'm just going to transfer that down here into my rule. So when I write u here, I'm going to actually be writing this, all of that. So I am going to just kind of write it that way. It's going to take me a bit of writing to get that done. So that means I'm going to have the cosine of the arctan of 1 times the cosine of the arc cosine of 1, arc cosine, or excuse me, of x. And then minus the sine of the arctangent of 1 times the sine of the arc cosine of x. And that's why I color code things, so that, you know, even though I get kind of close, at least I can tell that that is something going on there that I'm familiar with. Okay, so here we are, and now we've kind of figured each of these out. And so the cosine of the arctangent of 1 is going to just be the square root of 2 over 2. So we're going to put that there. And the cosine of the arc cosine of x is going to be just this x over 1. And that should make sense to us because it's the cosine of the arc cosine of x. We'll leave that minus sign there, and then the sine of the arctangent is going to be that square root of 2 over 2, and then the sine of the arc cosine of x is going to be this 1 minus x squared. Actually, I probably will write it as that fraction just to kind of let you know, because now I'm thinking about that. Everything else is a fraction, so that will help me understand things as I go. And so let me just do that underlining so I kind of know where I'm getting everything. So the cosine of the arctangent of 1 is the square root of 2 over 2 times this is, and maybe I could do that time, square root of 2 over 2, and then times, and the cosine of the arc cosine of x is just x over 1, and minus, and then the sine of the arctangent of 1 is the square root of 2 over 2, and then times the sine of the arc cosine of x is times the square root of 1 minus x squared over 1. And then when I kind of do all that, I get the square root of 2 times x is the square root of 2x. I'll write it that way, but just be cautious that that square root doesn't drift. And they're both over 2, so I can just write it as minus. And then this is the square root of 2 times the square root of 1 minus x squared all over 2, that common denominator of 2. And then let's see if I can kind of clean this up a little bit. And I'll maybe pull out that common factor of the square root of 2. Maybe that's what I would do. I'm just kind of looking here. I do have that common factor, square root of 2 times x minus the square root of 1 minus x squared all over 2. So I might write it like that as we go. So that is writing that as an algebraic expression because, you know, we had the x in there. Not everything was just a constant numerical value. Next one is number 5. And for number 5, it says use a distance formula to prove the cofunction identity or the difference formula. I think I said distance. Anyway, so the nice thing about that is we're just going to kind of plug in this relationship and kind of see what happens, and we should get to the sine of x. And so we're going to say the cosine of pi over 2 minus x is equal to the sine of x. And we're going to write a proof here, or proving that this is an identity. So we're going to work with one side or the other. The side I'm going to work with is the left-hand side. And I'm going to remind myself cosine of u minus v is cosine u cosine v plus sine u sine v. And so in this case, u is pi over 2, v is x. And we'll just kind of plug all that in and see what happens. So this is going to be cosine pi over 2 cosine x plus sine pi over 2 sine x, and I'll just kind of keep writing my equal sign. So just a little reminder, you know, if I do my table, sine is here, cosine is here, 0 to 90, and pi over 2 is 90. So sine is 1, cosine is 0. And so cosine of pi over 2 is 0, sine of pi over 2 is 1, and then I'll just plug those in. And so this will be cosine 0 times, and we'll leave that cosine x plus, and then sine of pi over 2, 1 times sine x. And so then when I kind of, this 0 times anything is 0, and I just get 1 times sine x, which is sine x equals sine x, and done. So you'll find that using these formulas to prove a cofunction identity, you know, think about the fact that that could help you. You know, when we were talking about what has to be memorized versus not, you have access to these difference formulas. So if you forget what the cosine of pi over 2 minus x is, because you haven't memorized that, you can, you know, it might take you a little longer, but you can go through that and kind of figure out what that is. Likewise, sometimes we just want to, you know, kind of simplify things. So this was kind of the proving of an identity where we know what the answer is. Then our next problem is simplify. So we don't know what the answer is. And then we kind of see what happens. So if you want to try these, go ahead and tell me. Otherwise, I will pause this, work it out, and then kind of go through it. Okay, so let's see how we do here. So first we need that formula, cosine parentheses u minus v equals cosine u cosine v minus sine u, or plus sine u sine v. And so I'll just write that using our theta and 3 pi over 2. Then I'll remind myself 3 pi over 2 kind of is right there on that quadrant. And then that is the point 0, negative 1, which is the cosine and the sine. So our sine of 3 pi over 2 is negative 1. Cosine of 3 pi over 2 is 0. Putting those in, cosine theta times 0 plus sine theta times -1, and 0 times cosine is 0, -1 times sine theta. And notice I put things in parentheses just to help myself, and we get negative sine theta. And again, let me know if you want to try the second one. Otherwise, we'll just move on and go through that as well. Okay, so for this one, we've got the tangent of parentheses u plus v equals the tangent of u plus the tangent of v over 1 minus tangent u tangent v. And so applying that, we get tangent theta plus tangent 3 pi over 1 minus tangent theta, tangent 3 pi. So theta just is going to stay theta, but we can look at that 3 pi. So remember, 3 pi is like a full revolution. So there's 1 pi, 2 pi, 3 pi goes all the way over there. So we're on the quadrant again. And the point there would be -1, 0. And then I'm just going to walk myself through what that means. So that's cosine comma sine. So the sine of 3 pi is 0. Cosine of 3 pi is -1. And then I'm going to do the tangent of 3 pi as just sine over cosine. So I get 0 over -1, which is 0. So the tangent of 3 pi is 0. So when I rewrite this, tangent theta plus 0 over 1 minus tangent theta times 0. And so then that gives me tangent theta over just plain 1, which is tangent theta. So that's my simplified version of that one. Now, the next thing we have is kind of a self-quiz, is what I'm calling it. So we're going to pause this and do that self-quiz, and then we'll go over these together as we look at that. So if you are in class, I have a handout to give you for trying these. And if you are just all distance or distance right now, then I also have them on this slide. And I think I put them on the YOLA site as a blank PDF also, just to give you more room. So here it is. Find the exact value of cosine of pi over 12 is like number 1. And I numbered them as they are found in the examples. Then prove the sine of x minus pi over 2 in parentheses is equal to the negative cosine x. And then simplify the sine of parentheses 3 pi over 2 minus pi, and the tangent of pi, or theta minus pi over 4. And so pause this, try those, and then I will go through them. So let's go over these then. And we've got the cosine of pi over 12. And so we need to make that into the cosine of a sum or difference. And we've talked about that before. I'm going to use pi over 3 minus pi over 4. And so this is the cosine of pi over 3 minus pi over 4 in parentheses. So it's cosine pi over 3 times cosine pi over 4 plus sine pi over 3, sine pi over 4. And we can find all of those on our table. So hopefully you did that. And cosine of pi over 3 is 1/2. Cosine of pi over 4 is square root of 2 over 2 plus sine of pi over 3 is square root of 3 over 2. Sine of pi over 4 is square root of 2 over 2. Just multiplying, we get that common denominator is going to be 4. Or when we multiply the denominators, we'll have a common denominator of 4. And so we get square root of 2 plus square root of 6 all over 4. And so that allows us to get an exact value of something that is not directly on the table that we've looked at. So we want to prove this next one. Sine of parentheses x minus pi over 2 and equals negative cosine x. So we're going to use our formula. Sine of a difference is sine cosine minus cosine sine. So that means it's going to be sine of x times cosine pi over 2 minus cosine x, sine of pi over 2, we want that to be equal to negative cosine x. Again, we can get these directly off of our table. Sine x stays sine x. Cosine pi over 2 is 0 minus cosine x sine pi over 2, which is 1. We want that to equal negative cosine x, and 0 times anything is 0, so we get negative cosine x equals negative cosine x for that one. Pause this if you need to. Moving on. Number 6, same kind of situation. We're going to use a difference formula. So that's sine cosine minus cosine sine. And so substituting those, we get sine of 3 pi over 2. And I accidentally hid my word sine, but I'll bring it back in a minute here. So that's sine 3 pi over 2 cosine theta minus cosine 3 pi over 2 sine theta. And there's my sine, but I guess I have my angle thing in the way of that as well. So 3 pi over 2 is on the quadrant. It's that 0, negative 1. And so we're going to get the sine of 3 pi over 2, which is negative 1, times cosine theta minus cosine 3 pi over 2, which is 0, times sine theta, and then that will be negative cosine theta. And oh, I can't even separate that from when I wrote it, whenever I wrote it. So then same situation over here, tangent. So we're going to have tangent theta minus tangent pi over 4 all over 1 plus tangent theta, tangent pi over 4. Just a little reminder, and I'm on the edge of my slide there, so my pi over 4 angle doesn't look super great, but it is, the tangent of pi over 4 is 1, and that's on our little table that we can generate, hopefully. And so then we get tangent theta minus 1 over 1 plus tangent theta times 1, and then that just gives us tangent theta minus 1 over 1 plus tangent theta. And we can leave it that way. I know some of the other sections we've done all this fancy, you know, like multiply by the conjugate, change it into blah, blah, blah. But here we'll just kind of leave that as is. And so that concludes part 3 of 5.4.